In this video, I'm going to cover 6 types of nonlinear deformers: the bend deformer, flare deformer, sine deformer, squash deformer, twist deformer, and wave deformer. Okay, so first thing, I want you to go to Create Polygon Primitives and turn Interactive Creation off. So it's located here, Polygon Primitives. Make sure this is unchecked. So what this is going to do is let Maya create a polygon primitive as soon as you hit the button, rather than waiting for you to drag the mouse to specify the size. And then to alter this polygon primitive, we'll use the node for that primitive in the attributes editor. And this can just make modeling a little faster sometimes. Okay, so first we're going to cover the bend deformer. So we need to make some geometry to deform. I'm going to use a cylinder with height 20 and 20 height subdivisions. So to make that, I'm just going to be in my polygon shelf, click the cylinder button, you'll see a cylinder pop up. I'm going to give it a height of 20 and 20 height subdivisions. I'll zoom out a bit, and I'll go ahead and go into shaded mode. Okay, so to create a deformer, you're going to want to be sure that you're in your animation menu set. So that's up here on the left. Go to the select the geometry, go to Create Deformers, or Nonlinear, choose Bend. So it'll look a bit like nothing happened. If I pop into wireframe mode, however, we'll see that there's a new thing in the scene. Pop back into shaded mode. And the way I like to manipulate these is to use the channel box over here to the right. If I choose the bend input, I can then make this deform in some way. So let's just test this out. Go ahead and highlight curvature by left clicking on it, move your mouse into the viewport, middle mouse, and drag, and you'll see your geometry start to deform. You can note that curvature can also be negative. So something important to remember is that when things deform like this, they have to have enough resolution or enough geometry to deform smoothly, or you're going to get weird results. That's why I used 20 height subdivisions, because I knew that would deform smoothly enough to demonstrate this. Okay, so let's talk about the attributes of the bend deformer. You've seen curvature will cause this to curve. You can make it all the way into a torus if you wish. Low bound and high bound determine where the bend effect starts and stops on the geometry. So if you manipulate that, you can see you can make a candy cane or J shape. You can do the same with the top. And last is envelope. This determines the overall effect. You'll see this on all of the deformers. This is present on all of them to give you something that's easy to animate. So when you want the effect of a deformer to change over time, rather than changing the individual settings, you can use this to animate. So you can think of this as like an overall filter for your deformers. Okay, that's the bend deformer. Next is the flare deformer. I'm going to create another cylinder. It's exactly the same. I'll select it, go to Create Deformers, Nonlinear, Flare. You'll see our flare node pop up here. Start Flare X will expand your geometry in the X direction on one end of the geometry that you've created. You can see they get bigger at the bottom. It's the start flare. Start flare Z will do the same thing, but in the Z axis. End flare X expands the geometry on the other end, and end flare Z expands the geometry on the other end in the Z direction. Curve determines how the flare transitions from one end to another. So let's make this top a bit smaller so we can see this. If it's positive, this transition will balloon out. If it's negative, it will curve inward. And at 0, the transition is linear. So we can see how we can make some neat shapes pretty quickly using deformers. And envelope, again, controls the overall effect. Low and high bound determine where the flare effect starts and ends. Alright, that's the flare deformer. Okay, now we're going to use the sine deformer. So I'm going to create the same cylinder. It's selected, so I'll go to Create Deformers, Nonlinear, Sine. And let's take a look at our attributes. Amplitude controls the height of the sine wave that's created. Wavelength controls the distance between the waves. So you can make it very wavy or not very wavy. Offset controls where the waves are actually formed in the geometry. Drop-off specifies how the amplitude decays. In other words, how the waves drop off back to neutral. Low and high bound control where the deformation begins and ends. So you're going to make it start at the end of the geometry or somewhere in the middle. And the same with high bound. Alright, that's the sine deformer. Okay, now we're going to demo the squash deformer. So I'll create the same cylinder. Create deformers, nonlinear, squash. Let's take a look at the inputs. Factor controls the amount of squash, and note that this can be negative. So you can just see this kind of pulling the cylinder up and out, pushing it down and in. You can see how this would be useful in animation. Take it like that. Expand allows you to increase or decrease the width of the geometry when it's squashed. So you can see that expand out, so the squash becomes even more pronounced if we want. Max expand position allows you to move the center of the squash effect along your geometry. So you can see it move to the top or the bottom. Start and end smoothness allows you to control the drop off of the squash effect. So I can make that more extreme or less. Same thing for end smoothness. And low and high bound control where the deformation begins and ends in the same way that it has for other deformers. Envelope again is your animation node. So you can control the overall effect without adjusting the individual attributes. So that is the squash deformer. Okay, now let's demo the twist deformer. For this deformer, I'm going to use a cube, and that'll just be so that we can see the results a bit easier. So I'll create a cube, and I would like it to have a height of 20 and 20 height subdivisions. So similar to the cylinder, but only 4 sides. Create deformers, nonlinear, twist, and let's select the attributes. Start and end angle are how much the geometry will twist. And you can adjust both of them if you want something to twist and untwist at different ends. Low and high bound control where the effect starts or finishes. And then envelope is your overall controller. Alright, that's the twist deformer. Okay, our last deformer is the wave deformer. And we're going to apply this to a plane just so we can see the effect a bit easier. So create a plane. This is a bit small, so I'm going to scale this up so it's easier to see. I also want this to have 20 subdivisions in each direction. And go ahead and bring this up above the grid a little bit, just so we can see that easier. Okay, with the geometry selected, go to Create Deformers, Nonlinear, Wave, and let's take a look at the attributes. Amplitude controls the height of the deformation. Wavelength controls the distance between the waves. Offset controls where the waves are formed in the geometry. So we can cause them to start at different places. It's a little hard to see because it moves pretty quickly. Drop-off controls the fall-off of the outermost waves. Drop-off position will control which waves the drop-off affects. Min and max radius act like low and high bound. They determine where the effect starts or stops. And of course we have envelope, which controls the presence or absence of the whole effect. Okay, that's the wave deformer. Okay, so let's talk about, once a deformer is applied to some geometry, what can happen to it and what I can do with that geometry. So if you've applied deformers and tried to rotate your geometry, a lot of times you'll get really kind of weird results. Not exactly what I expected to happen here. So how do I rotate this sideways once I've applied a deformer to it? Well, one way is to make sure that both the deformer and the geometry are selected. So I've box selected those. You can also look in your outliner, make sure in this case that both pCube1 and twist handle are selected. And now when I rotate, the deformer goes along with the geometry, and so the relationship stays the same and no kind of weird deformations result. So let's say that I've deformed this and I don't really want to deal with this twist handle anymore. This is exactly the way I want my geometry to stay forever. The way that you can basically bake this into the mesh or make it permanent is to delete the history on this object. So because Maya is node-based, history or previous nodes influence the current geometry. For example, this is a cube with a twist deformer. I can still see the twist attributes. I can still see my cube attributes. So if I delete the history on this object, that will get rid of these previous nodes, and the object will just be the geometry that you see. It won't have any nodes feeding into it. This won't change your undo queue or anything like that. It'll just bake the changes you've made into this geometry. Alright, so how do you do that? You select the geometry, you go to Edit, Delete by Type, History, Delete All by Type, History. The difference in this is Delete by Type, History will delete the history on the object you have selected. Delete All by Type, History will delete the history on all objects in your scene. You'll note that you also have the option to delete only non-deformer history. And this is pretty useful for when you use deformers to animate. You're often going to want to delete history on something, but leave the deformers in place so that you can animate with the deformers. So I'll go ahead and delete by type history. You'll see that my deformer disappeared. It's not in the outliner anymore. It's no longer feeding into my shape. Those nodes are gone. This geometry just is the way it is. You might ask, why didn't I just delete the deformer? Well, let's undo and see what happens if I select the deformer by itself and then hit delete. You'll see that my geometry went back to its previous state. What I deleted was the node that was influencing it. So the node no longer influences it. It returns to its previous state. What you have to do to bake that deformation in is to delete the history and not just the node. Okay, I wanted to talk about grouping and pivots. So you'll see here I've created 3 spheres. Kind of see their spatial relationships to each other. 3 separate objects. If we take a look at the outliner, make sure that show all is turned on. So now I'll see my spheres here. Let's say I group these. I'll select them all. Hit Control G to group. I've got this group node here. You'll notice that the pivot, or the point that it transforms from, by default goes to the origin. So this can be fine if all we're doing is moving this around. It doesn't really make much difference where that pivot is. But if I want to rotate this, for example, so now rather than rotate from the middle of the spheres like we might expect, it's rotating from the origin. And this can be useful too, having that spatial relationship by default, but a lot of times what we're going to want is to rotate a group kind of based on the center, the geometric center of the objects in the group. So to do that, there's a couple of ways. One is that if I've created the group already, I can make sure my group is selected, modify center pivot. When you click that, you'll see that the pivot now changes to geometric average center of the geometry, and I can rotate and perhaps get a result that's more expected or intuitive. The other way to make this happen is in our group options. So that's under Edit, Group in the options box. We can have the pivot automatically go to the center instead of the origin. I leave this on default and then center my pivots as necessary. You could put this on center. Either way would be fine. I don't see any problem with either of these presets. That's how you can change it if you always want that to happen. Okay, so that's grouping and pivots.